Figure 4 shows a sketch of y equals g of x, which is defined slightly differently depending on whether we're below or above 2. Actually, this is known as a piecewise function because of that feature. Find the value of g of 0, or g of 0, if I'm putting 0 in, I'm actually going to put it into the top part because 0 is less than 2. That will give me 0 minus 2, which is minus 2, squared, 4, plus 1, I'm going to get 5. And then g of 0 become g of 5. No need to actually find the whole composite function. In fact, that would be extremely challenging given that it is a piecewise function. Now I've got g of 5. 5 is greater than 2, so we put it into the bottom one. 20 minus 7 gives me 13. Now find all values of x for which g of x is greater than 28. So let's find out where it's equal to 28. I'm just going to draw this horizontal line. That is y equals 28. And I want to find these 2 points here, which will lead me to x being bigger than this value or less than this value here. So I'll first of all deal with the 4x minus 7, I think, because that's slightly easier. I'm going to set 4x minus 7 equal to 28. That's actually going to be this point here on the right. So 4x is 35, x is 35 over 4. And then I want this point here. For that, I'm going to, I probably should just say that this is for x greater than 2, and we're okay with that. And now I've got x is less than or equal to 2. I'm going to be doing x minus 2 squared plus 1 is equal to 28. So x minus 2 squared is 27. I don't need to expand this or anything, just square root both sides. But don't forget the plus or minus. Plus or minus the square root of 27, that actually becomes 3 root 3. So x is 2 minus 3 root 3, or 2 plus 3 root 3. But this one's going to be greater than 2, so I'm going to reject it. It's not actually a physical solution, it's just a solution to my quadratic. The 2 minus 3 root 3 will be absolutely fine, and that's what it is here. So to find all the values, well, it's going to be x is less than 2 minus 3 root 3, where the graph goes above, or x is greater than 35 over 4 again, where it goes above. Sorry, the function h is defined very similarly, but just for x less than or equal to 2, not for greater than. Explain why h has an inverse, but g does not. Well, from the graph, we've already found two values of x that give us 28. This is a many-to-one function. G is many to 1. If you try and do an inverse mapping, it would swap around and be 1 to many, which is not defined as a function. Whereas h is actually going to be 1 to 1, because it will just be this part here, actually. A single value of x maps onto a single value of y. And then that allows you to do the mapping the other way. Y will map back onto x. Great. Finally, we're asked to solve the equation inverse of h is equal to minus a half. Now, you do not need to calculate the inverse. What we need to do instead is just slightly modify this equation. We can do that by either understanding how the inverse works or finding h of both sides. Because when you take the inverse and then do the opposite, you get back to x. So you could go straight to this line in theory. That is going to be so much easier. Actually, all we need to do is substitute minus a half into this function. Nothing more than that. So it will be minus a half minus 2 all squared. Sorry, that squared has been a bit hidden, but it's there. Plus 1. And that ends up, if you put it in your calculator, as 29/4. Good job. Keep practicing. Well done.